Hello students, in the previous class we have learnt the different types of methods of preparation of aldehyde. That is, one is from alcohols, oxidation of alcohol, second one is by dehydrogenation of alcohols, and the third one is with respect to Rosamond reduction reaction. And now the fourth method we are going to study. So here students, the fourth method is from carboxylic acids, that is catalytic decomposition of carboxylic acids. When we pass the vapors of carboxylic acid over heated manganese oxide at 573 Kelvin, we will get carbonyl compounds. That is, depending upon the acid that we are using, we get whether aldehyde or what ketones. Example: when vapors of methanoic acid are passed over manganese oxide at 573 Kelvin, formaldehyde is obtained. So in this reaction, two molecules of methanoic acid, which is also called as what, formic acid, when passed over manganese oxide at 573 Kelvin, we will be getting formaldehyde, and it is represented as here. So here what happens, one of the OH group of formic acid will be lost along with the formate group of the other molecule of formic acid. So this part is lost, and here we can see that what this is lost as a CO2, and this OH and H is lost in the form of H2O. So in the second example students, we are using here ethanoic acid, which is also called as what, acetic acid, and the second molecule is the same with just like what, the methanoic acid or the formic acid. Again here also the same thing, the OH group is lost from ethanoic acid, and the formate group which is lost from what, formic acid. So this is the formate group here, so this will be what, eliminated. So here we will get what, aldehyde other than what, formaldehyde. So the aldehyde is CH3, C double bond O and H, and we will be having the loss of water molecule H2O and water CO2. The interesting fact we should try to understand is that students, if the two acid used are the same, that is what, methanoic acid, then we will be getting what, formaldehyde. But if one of the acid is carboxylic acid other than formic acid, then we will be getting aldehyde other than formaldehyde. So you can see in the second example here, I'll be what, circling here in the second example. So here we are having what, ethanoic acid, or it is also called as what, acetic acid, right? So here this alkyl group is not H, it is a CH3, so therefore we are ending with here CH3. It means that of the two carboxylic acid used, if one of the acid is other than formic acid, then we will be ending with an aldehyde but not formaldehyde. So in the next example, we are using benzoic acid, which is having the formula C6H5 C double bond OH, and the other acid is again just like what the again first two examples, that is formic acid. Here also the same thing, OH group of benzoic acid is lost along with the formate group of the formic acid, and we will be having C6H5 C double bond OH. So this becomes C6H5 C double bond OH with the loss of one molecule of water, H2O plus CO2. So this C6H5 C double bond OH is benzaldehyde. In fact, it is an aromatic aldehyde. Is it clear, students? Next we are having a note, students, that is, if the two molecules of acetic acid, if we are going to use, then we are having the product ketones are obtained under the same conditions of temperature along with the same catalyst, that is manganese oxide. Here what happens, two molecules of acetic acid we are using, and here the OH group of one carboxylic acid, and with the other part of the carboxylic acid we are going to eliminate this, and we will be writing the product, that is CH3, then C double bond O and CH3 plus a molecule of H2O and one molecule of carbon dioxide are lost, and this is nothing but acetone. So we are ending with the product that is called as ketone. When if the two molecules of acetic acid are used, then we are having what? Ketones, that is acetone. The second note is that students, of the two acids used, okay, of the two acids used, if one is methanoic acid, then the product is what? Aldehyde, or else then the product will be what? Ketone. This we have already learned. Now I have just mentioned one note, right? The next method is, students, by dry distillation of calcium salts of carboxylic acids. Here we have to understand the typical representation of calcium salts of carboxylic acid. I'll be having one example here. So let me take it as HC double bond O and then followed by OH plus calcium hydroxide. So calcium hydroxide is a dibasic acid, so therefore we have to write 2OH for that. So therefore I will write here OH, and this is another OH here. So I have to treat it with another molecule of what? Carboxylic acid. So let me take it as what? Formic acid. So here OH, then followed by C double bond O and H. So this is an acid, and even this also is an acid, but this is what? Base. Calcium hydroxide is a base, it is a dibasic acid, right? So in order to neutralize calcium hydroxide, we require two molecules of formic acid. Here what happens when we treat an acid and a base undergoes neutralization reaction, and we are losing here one molecule of water, that is H2, and here also we are losing one molecule of water, H2. Then the product left behind is that we can see here. I will write here H, C double bond O and O. Now this oxygen is going to connect with what? This calcium here. So I'll write here what? Calcium, and this calcium is going to connect with this oxygen. So therefore I will write here O, then followed by C, then followed by double bond O and H. So therefore this is formic acid, even this also is formic acid. Now calcium is a divalent, so in order to neutralize, we require two molecules of what? Calcium. Two molecules of formic acid. So therefore this salt is called as calcium, then followed by formate. It is nothing but called as calcium formate. Now suppose if I have taken here a CH3, then this would have become acetic acid. So here I have to write here what? CH3, isn't it? So two molecules of acetic acid are undergoing neutralization with calcium hydroxide. So therefore the compound would have become here CH3, and here also what? CH3. Now this is called as a calcium acetate. It is a salt of water, calcium acetate. And if I have written here as a CH2, and if I have written here as a CH3, now this is a 3-carbon carboxylic acid. So here I would have written here as CH2, and here I would have written as what? CH3. Then here also what I have to do? I have to write it as 2, then followed by what? CH3 single bond, and here also CH3 single bond. Now this is called as calcium salt of propanoate. It means that calcium hydroxide is going to combine with a carboxylic acid containing 3 carbon. So therefore it is called as calcium propanoate. Similarly, if I increase one more carbon, then the compound would have become calcium butanoate, calcium pentanoate, etc. and etc. I hope you understood this, students, right? Now students, in this example, when calcium formate is heated alone, okay, it is going to be heated alone, it gives formaldehyde. Now let us see how it is going to undergo decomposition, right? So that is dry distillation. So this part is going to be lost in the form of what? Calcium carbonate, right? So therefore remaining part is what? H, C double bond O and H. So therefore I can write it as here H, then C double bond O and H. So this compound is formaldehyde, and the remaining part is nothing but calcium carbonate, CaCO3. Other aldehydes can be prepared. So in earlier example we have prepared only formaldehyde, but if you want to prepare aldehyde other than formaldehyde, means then we have to heat equimolar mixture of calcium formate. Okay, so calcium formate, I'm going to write it here Ca, then followed by O, again here also O, then followed by C double bond O and H. So this becomes what? Calcium formate. Okay, and a calcium salt of carboxylic acid, which I have written here. Okay, I don't know what is R. It can be any alkyl group, so that part is called as calcium salt of carboxylic acid. So when this compound is subjected to heating, so therefore that is nothing but it is undergoing decomposition or dry distillation, then what we can say that this whole part is lost. This whole part is lost, and you can see that this R is going to combine with this COH, which has been mentioned here, and this R is going to be a part of C double bond OH. So altogether there are two molecules of R, then followed by C double bond OH, and whatever the part that has been lost during distillation, it is nothing but two molecules of calcium carbonate. So this becomes an important step to prepare aldehydes other than water formaldehydes. Here R is completely different. If R is equal to CH3, it becomes what? Acetaldehyde, right students? So I have written here this is calcium formate and the product is nothing but an aldehyde, but it is other than formaldehyde. So in the next example students, calcium acetate on heating with calcium formate gives acetaldehyde. So therefore we have to use two different types of calcium salts of carboxylic acid. So first one is calcium acetate, which has been written here very neatly here, calcium acetate, and this is treated with water calcium formate now, right? So on heating, here what happens is that this CH3 part, so here we are going to cleave this part, and this part is cleaved along with this part here now. So therefore what I can say that the products formed are, now this is the CH3 part here, CH3, and here also CH3. So this part are going with C double bond OH and this is C double bond OH. So altogether we are having here two molecules of CH3, then C double bond O and H. So therefore this is ethanol, ETHANAL, or it is also called as acetaldehyde, ACETALDEHYD, plus two molecules of calcium carbonate, CaCO3. But this method, whatever we have prepared, that is what ethanol, okay, by this reaction, right students? But this method is suitable only for the preparation of formaldehyde, but not for other aldehydes. This is so because when a mixture of calcium acetate and calcium formate are subjected to dry distillation, it will be giving three products. The first one is a formaldehyde, second one is acetaldehyde, and the third one is water ketone. Let us try to understand how this is possible. Now here I have given the description students. So when calcium acetate is alone subjected to dry distillation, it will be losing a molecule of water calcium carbonate. So that calcium carbonate is this part. So this calcium carbonate is lost and remains only water, the acetone part. So here CH3, then C double bond O, then followed by CH3 plus CaCO3. So therefore we are ending with an acetone, that is what a ketone, right? So this part ketone I have underlined here, so I hope you are understanding that, right? So calcium formate when subjected to alone dry distillation, so here this part is going to be lost in the form of calcium carbonate and remains here H, C double bond O and H. So therefore we can write here H, C double bond O and H plus CaCO3. So this is nothing but formaldehyde. So as I have already written here, that is here, I hope I am underlining here, so you are seeing this, okay, formaldehyde. So this is formaldehyde. Is it clear students? And acetaldehyde I have written here, okay, that is a CH3 C double bond O, which we have just understood here, that is with respect to this example here, that is what acetaldehyde. So altogether in the sense this method is only suitable for the preparation of water formaldehyde, but not other aldehydes. If at all if you go for other aldehyde, then we are getting nearly around water 3 products that we have seen just now here. I hope you are able to see this, all the 3 products here. So this is acetaldehyde and we are having a ketone, that is acetone, and this is formaldehyde. Is it clear students? So here we are having a question, students. How do you prepare benzaldehyde, that is A, and B is butane 2-one, and C is cyclopentane 1-one from calcium salts of water carboxylic acids? You have to prepare the benzaldehyde. Remaining two I will be explaining here. So in this solution B, butane 2-one, let us first write the structure of butane 2-one, that is CH3 C double bond O, then followed by CH2, then followed by CH2, right students? 4 carbon, so I have to just erase here, so that has to become CH3. So altogether 4 carbon atoms. So here what we have to understand is that this CH3 part is coming from one type of calcium salt of carboxylic acid, and the remaining part, that is C double bond O, then CH2 and CH3 is coming from another part of water calcium salt of carboxylic acid. Is it clear, students? So if it is a CH3 part here, so therefore that becomes a calcium acetate. So let me write it as CH3 C double bond O, and here also CH3 C double bond O, then followed by O. So it is a calcium salt of acetate. So this has to be treated with 3 carbon, so that becomes calcium propanoate. So Ca and O, then followed by C double bond O, then CH2, then followed by CH3. So here also O, then C double bond O, CH2 and CH3. When these two are subjected to water heating, that is dry distillation, right? I'm sorry, so here dry distillation, so just writing it as heat. Then here what happens is that the part that is lost, we have to remember here, is CH3. So the bond get dissociated from here, CH3, then followed by this part, right? So this part is lost here. So when this part is lost, then the product we are having so CH3, then followed by OCH2 CH3, and here also CH3, then followed by CO CH2 CH3. So altogether 2 molecules. So 2 molecules of CH3 C double bond O, then followed by CH2 and CH3 plus 2 molecules of calcium carbonate. Thus we are having the product that is butane 2-one. So the next solution is for cyclopentane 1-one. I have written here cyclopentane 1-one, and its geometrical structure is written as here. I hope you are able to see this. Now students, in order to prepare cyclopentane 1-one from calcium salts of dry carboxylic acid, so far we have learnt the preparation of aldehydes and ketones which are open chain, but here we are having a cyclic compound, cyclopentane 1-one. Under such conditions we should try to take water dicarboxylic acid where the 2 COOH groups are present within the same molecule. So there are some typical examples here. So oxalic acid, we are having the formula COOH twice, and it is a malanoic acid, so it is a CH2 COOH taken as twice. So the difference is that if we see, oxalic acid is a 2 carbon compound, malanoic acid is a 3 carbon. So I hope you are able to see here 1, 2 and 3. Succinic acid is a 4 carbon dicarboxylic acid. Glutaric acid is a 5 carbon dicarboxylic acid, and adipic acid is a 6 carbon dicarboxylic acid. In fact, these we are going to learn in the topic called as carboxylic acid, and in fact we are having a code also. This is oh my such great apple pie, as sweet as sugar. Okay, so there are many different types of names. In order to understand all those things, we'll be concentrating this part in carboxylic acids. Now the fact we should try to remember here, students, is that so here in this compound there are 5 carbon. Okay, so, and we know that whenever these calcium salts of carboxylic acid are subjected to dry distillation, so one of the side product is a calcium carbonate. I hope you remember this. Okay, so this carbon is lost there when we subject the one molecule. So one of the carbon is lost in the form of water carbonate, and that to water calcium carbonate, right? So we have to understand that when a cyclic compound is to be obtained, then we have to choose one carbon atom greater. So therefore I have to take what a 6 carbon dicarboxylic acid in order to obtain cyclopentane 1-one. So let us try to understand how that product is obtained. Now let me write it as adipic acid. So adipic acid already it has been written here, so I'll be writing here once again CH2, then followed by CH2, here also CH2, here also CH2, then C double bond O, then C double bond O. But I am not taking what adipic acid, I have to take what calcium salt of adipate. So therefore I will be writing here 1 minute. So here what it becomes O, then followed by O, then followed by water, calcium. So this becomes the calcium salt of adipic acid. It is simply called as calcium adipate. If this molecule is subjected to dry distillation, so I will be writing here heating, then we can remember that one of the carbon is lost in the form of calcium carbonate. So therefore I will be writing this is lost in the form of calcium carbonate. So I'll write here minus CaCO3, then this bond will be connected to what, this carbon. So therefore we can write the product as CH2, then followed by CH2, here also CH2, and here also CH2, and that is linked with this carbon whose valence is 4, and the product is called as cyclopentane 1-one. Is it clear, students? So if you feel this video, if you feel this video a good one, kindly like the video and share the video. Thank you for watching.